Okay, I haven't. All right, we are live on uh, YouTube, inshallah.
Okay.
Okay, I'm going to give you permission to share screen.
Okay.
Hey, can you hear me?
Yes, now I can hear you.
Okay. So I'm going to start the recording, and we are live as well on YouTube.
Okay.
Okay, and record to the cloud. Yeah, you can start your presentation, inshallah.
Okay.
Um, Good afternoon to everyone who is attending this event from different parts of the world. We have our graduate, Inchara, who will be demonstrating her project. And Inchara, you can take it away.
Yes. I've shared.
Yeah, I can see your screen and you can start.
Yes. Good afternoon, everybody. I'm Inchara, and I'll be presenting a project on e-commerce sentiment prediction model. I'll give a quick introduction onto this. So basically, when a company launches its website, right, it will there will be a main concept is to sell item and the end user is the consumer. There are basically many websites for this, like Amazon, Flipkart, Myntra, etc. In this concept, so if we have a client named eBus, and they have a huge market share in many fields, and it's selling the products in various categories like household essentials, books, personal care products, medicines, cosmetics, various things. And they're an e-commerce business, and they want to grow their business quickly, and they are very competition, right? So as a machine learning engineer, here what we are trying to do is to predict the user sentiment towards a product. And why is this required will be even further, it can be used to give up recommendations to the user. Like there will be, you when you buy, you will give ratings, you give your comments. So if you like it, the products, it will be more convenient and more user friendly to give product recommendations, right? So that we can achieve from this. So here I'll be predicting the user sentiment towards the product. And for that, we are using the machine learning model. We're going to see like which model is efficient in predicting the user sentiment for various products. So the steps I taken to achieve this goal is to import all the necessary libraries to load and then loading the data, and then to exploratory data analysis. I'll go one on one, just steps here. And then there will be a pre-processing, there will be a feature extractions. The final stage would be a model building, all the necessary model. I've taken like 5 models into consideration here. Then we'll be going for model evaluation. So this will be the presentation today. I'll share my code now. Just a second. Yes. You can see my screen, right?
Yes, Inshara, go on.
Okay. So the first step would be importing necessary modules. Basically, these are all the necessary modules we need for our machine learning models. So I'll go on them when during their time. Okay. So first would be the main pandas and seaborn. These are all for the visualization, like processing of the data. For that will be used. So first thing I've done is to load the data here. This is the data set of and it's of 30,000 rows and 15 columns data set we have here, and this is a simple understanding for our data set, all these columns, and we have some null values here, and these are data types of them currently. And yes, it's a 3.4 MB data set. Okay, and now I'll be here. I've printed the first 5 rows of the data set. So here I'll be explaining you what it is. So we have a ID, we have brand, like unique ID for each of the particular product, the name of the brand of the product. They have categories, which categories it's going to be in, either household or books or personal care products, medicines, like that, and the manufacturer of the product, and the name of the product to which the user has given the review for, and then the date on which the review has been given by the user, and then when a particular user has purchased the product or not, when they have given the user, when a particular user has recommended the product or not. So these columns give those particular they have recommended or not. If you have not recommended the product, if you have not purchased it, if you have purchased it. So these things are in our data set, and then the review rating given by the user for a particular product, and then the review text. There's a written text as well. Will be playing a major role, and the title given while giving the review, and then the city of the user residence, if they've provided those values, these things, and the unique identification for the individual user. Overall, this is our target, the overall sentiment of the user for a particular product. So basically, this is you have a target here to achieve. Yes. So here we'll start with the data cleaning. So this particular model, basically, this will gives us the count and the percentage of the null values present in the data set. Yes. So this one will sort the values from the like larger to the smaller values, and we will get the count in percentage of the columns with their null values. So as you can see, 99.4%, the above 20%, let's say in the start, we're seeing this. There's a huge number of null values. So I've considered to remove those particular rows, columns from the data. So that is what it's done here. So for the cleaning, I've taken a copy and dropped the value of those 3 columns. So then the remaining rest of the columns is here. So we'll try to see the value counts for the first one, which has 8.56% of null values. So this is the reviews they recommend, if they have recommend. So you can see most of it is it true. Everyone has recommended whatever in the values. So this particular column, it's not so required for the to see the user sentiment. 94% of the data is having true value. Not provides a useful information for the model to learn. So we will drop this field. So the next is review title. This particular column is important for the analysis. So it will basically they'll tell good, bad, excellent, or not satisfied. These particular will come in the reviews title in the short form itself, right? So we will so since the null values are like 0.63, right, we will remove just the rows of the data set from them, like all the null values we will delete it. So after deleting the particular rows which are null in the reviews title column, this is our next set of values that are null. So manufacturer, I think it's not required for the particular the goal we have. So I've neglected it here. And next is reviews username. For the analysis, it's not particularly required, but yeah, yet I've done a simple like remove the rows from the data set. What are all these all? I've removed the rows which are like null. So those I've removed here. So next is the user sentiment. We can see there's only one particular row that is null, right? We can try to fill that particular by seeing how that particular row is. So they have given a review like my kids absolutely love this film and they have given a 5 rating, a super hit. So as seeing here the review title and the rating, we can see the overall sentiment is positive since the one record we have updated with a user sentiment as positive. Sorry. So these are the next 5 after clean data. I'll be neglecting these 2 for the later analysis, the particular columns. And we'll go for the analysis of our data to see how the review ratings are. First, the review rating column, most of the ratings from the user have been on the higher side. Here, most of the ratings are 5. It's a pretty imbalance as a user sentiment should be aligned with the rating. We will see this later on. We'll try to, we're doing the model processing, we'll try to balance it. So next is top 5 brands with negative reviews. So these are the top 5 brands with the negative reviews and the top 5 brands with the positive reviews. This is the product that has both top 5, it's in the top 5 negative and positive reviews. So why is that? Is because the brands that are considered in this data, almost 35% of it is from the Clorox. So there's a high Clorox products here and reviews, ratings and all that. So it has got a more amount of positive and negative rating as well. So next we'll be checking the review count based on the reviewer, and then another analysis of it. So for that, we need to convert this particular review date into a date type. It's not in the date type, it's in object type. And then we will get the year component from the date. So this particular will convert that date into object into a date type, and if there's any other inconvenience, it will convert it into a null null value. So it has converted the review date. So the analysis with that distribution of the reviews over the year is here. There's one more analysis we can see. There's more review has been done on the 2014. So this is another analysis. Then is the checking movie categories by rating. One more category is a movie category. So we can see there has been, it's a very interesting thing. So here, there are brands which have negative sentiments, but much higher review rating. There's a positive review rating, which has to have like 5, right, to get a positive rating, and between 4 5, yes. But here also there are negative the sentiment, but it's also in the higher rate of rating. So this is a very different, also not a nice thing here. So I'll not be considering review rating when I'm trying to do the user sentiment. So it's one of the analysis will be so that's why we'll be predicting the user sentiment based on the reviews given in the text reviews, and not on the numbers like 4 5 ratings given. So for that will be converted. All the types are in objects. So we'll be converting the main here. We'll be doing a pre-processing. Before that, the type conversion is done. All of the brands, categories, names all been converted into a string value, string data type. So coming to the main part. Here, as I said, I'll be taking the reviews text and the reviews title. Reviews text meaning there'll be a text of their like a huge few sentences written on the product, and the title will be a small title. I can show you here. The review title. Yes, here they've written a small things on it, just awesome, good, good, disappointed, irritation, and there's a text also. So we'll be combining these two to get a user sentiment, which will be much better and easier, and also a way to reduce the number of columns. So we'll be combining that and making a separate data set. So these I've removed, as I told earlier, I've removed these particular columns as they're not required. So next is for the sentiment analysis. This is the data frame that I'm considering with the combined all the review title and review given, and then the user sentiment, the ID and name. So for that, since we want to, this is a text-based model, right? Text processing needs to be done. So for that, the first step is to handle the punctuations. So we need to clean the text and remove all the unnecessary elements apart from like those words, and there may be a white space. No question mark, comma, exclamatory marks, anything, no such things are required. So first that is done on the particular column. So here all the sentences will be lowered case, and then a pattern is written for regular expression to remove the punctuation. This will particularly replace all of the punctuation with a white, with just a small space string, nothing actually. So that has been applied to this particular reviews campaign. So earlier it was like this. Now you can see there's no dots, anything of such. So like that it will be. Then to further improvise and further process our text-based processing, we will do the handling stop words on it. So stop words in a particular way, they are the English words that doesn't add no much bigger meaning to the sentence. These are all the stop words you can see from the English words. So they don't add but any higher meaning to your sentence. So these things can be removed for this analysis. So here that has been done. So it's a function that will return the words which are not stop words. So we'll convert them into low words and all the lower case, and all the words will be sentences will be split into words. So that words which are not stop words will be given to will be applied to our particular that reviews cleaned row column, sorry, that we have applied here, and we name that as reviews cleaned. Right now there will be not the I, the, this, these things will be removed from our sentences. Why this been done is because to predict a user sentiment, what do we need? We need like good, we love the album, like it's a good flavor, like that we need it. We don't need it this, that, it's a very, all that, not required. So then this is another step that needs to be done, is handling lemmatization, which is, in a simple words to say, it's like you have a word that's having like, I love this, I love pizza, okay, and then you split that word into a singular and binary, like you separate that into a love and pizza. Next you'll do is love pizza, so they have a two different meaning. So here when we apply this, it will be a better for our a better way to understand the user sentiment. So that has been done. So this is the final, how I'm just showing the first two rows here. So this is how it is. So for this, we can do is apply our machine learning models to predict the user sentiment. So here's one more, after all the lemmatization done, just a distribution of the reviews character length. We can see the character length is up to like more than 12,000 here. So before that, I've just encoded our user sentiment into zeros and ones, because it will be easier to encode when we do encoding. So that is done here. Basically negative is 0 and positive is 1. And that will be encoded onto the user sentiment. And this is our new row. Just replaced it with the encode. So this is, I'll be dropping this user sentiment column. Dropped it. And this is the next two rows. So this is like cloud visualizations of the top 30 words in the review. Like these are the words that we are mostly seeing in our reviewed lemmatization done column. So basically here, the word cloud model, what it will do, it will give us the maximum 30 words that has been used in a way, in a visualization way from this word cloud function. And it will skip all the stop words also here. And this is the way it looks. So next is feature extraction. Here, feature extraction is done to convert raw text into a matrix of TF-IDF features. So what is this is, basically this one does the part of, like, you have this sentence, and here it will remove 95% of the most occurring words, and it will remove the 5% of only the 5% occurring words. So it will give us a balance. There will be no noise in our particular features. There will be no noise from this. So no stop words will be applied for this. So this will be used. And then coming to the model fitting features here, sorry, the training and testing here. For that, the X we are taking is the reviews lemmatized column. So we have fitted that into our particular TFT feature extraction model, and the Y's are we're trying to predict the user sentiment, right? That is our Y. So once that is fit, this is our splitting the data into training and testing with a test size of 20%, like 0.2. So this is our train and test shape. So we can see that there is an imbalance, right? So I'll show it here. So the value counts, the user predicting, saying a positive sentiment is 88%. A user with a negative sentiment is just 11%. So what we're trying to predict is the main user sentiment. So we are trying to balance it out by using a SMOT model. SMOT technique. This is a oversampling method that generates synthetic sample for the minority classes. So it will do the oversampling on the minority. Since we have a less number of negative things, negative reviews, it's gonna oversample it and make it a balance. So after applying that particular into our X and Y train, the training data set, this is our final balanced training data. So now the positive and negative sentiments, they have an equal number of rows. This will next step is a model building. Here I've taken the 5 models. So before that, so basically we're doing is to predict, to see the evaluation, right? Like what is the accuracy, the sensitivity, recall, the specificity, precision, and F1 score. So for that, there's a function. We will pass our particular model into this function with the X test and Y test. So what it will do, it will give us a predicted Y predict. The predicted value. It will create a confusion matrix. Confusion matrix will provide an actual and predicted label data, and then all these values will get calculated, the true positive, true negative, false positive, and false negatives. All this gets calculated, and this will be used in the formula for predicting all these 5 matrices that we are using to see which model is better at predicting. All right, so this is the and then the comparison results. So we will see that further. So this has deleted. Okay. So first thing is SVC classifier. So here we are passing the SVC model to our X-train, Y-train, and we'll be doing the evaluation metrics of it, passing the SVM model and then the X test and Y test. From that, we are getting the models matrices as this. So the comparison, we can do it later. So this, all the data will be added to our evaluation scores function. So that has predicted, given out these results. So next is the KNN classifier. This one, it will be helpful when there is like data set is small, this particular classifier, and SVC is good when there's a balanced and a large data set. So this particular model, I have tried to create the and train the KNN classifier here. You can see created an object, and this is the KNN classifier we are passing and fitting the X-train and Y-train. Same will be done there. I'll just add that step over there. And then, so this has been trained, and so for that we will be this KNN. I will particular fitted trained model. I'll be passing it to the evaluation scores function that I have created with the testing data. So it will give us the evaluation metrics over here. Actually, this model is not done very nicely, so I didn't go for the hyperparameter tuning. So focus done over here. For the logistic regression, there is a random forest. For that, I've done, particularly we'll take the base model. In this, the LibRiner solver is commonly used for the binary classification problems. So also when there's a large data set, so this has been taken and we have trained the model here, and we are passing the trained model with the X test and Y test to see our matrices. So this is our matrices here. We have a F1 score of 93%. So it's a comparatively good. For that, we have done the hyperparameter tuning. So this one, if I give the explanation for the C and solver, it's a regularization technique to prevent the overfitting in the machine learning models. So that has been added, and the solver libliner, it's used for the binary classification. So this has been given to the grid search CV. So this will particularly do is it will cross validates it 5 times. Like the model samples, it will, the particular data will be split into 5 different data sets, and it will be trained and tested. So that has been done. This will give us verbosa true will give us the logs of the logs output, and this will use njobs -1 will use all the processors, and as an evaluation to see which particular combination of parameters are good, we are using F1 scoring. So first this hyperparameter will be trained, and then the best parameters are these it has evaluated. So that particular parameter will be used to evaluate the scores again after the hyperparameter tuning. So now the scores are like this. So the base model and the tune model, if we goes for the F1 score, it has improved. The accuracy also improved. There's no much higher change though. Yes. So next is a random forest. Random forest classifier will take for the base model, will just train with the random forest classifier, and then the evaluation scores are as like this. It has a 95% F1 score and 91% accuracy, and all of these. The specificity is 0.40. So for the hyperparameter tuning, I've taken the N estimators. This is particularly will the number of decision trees that will be taken from 10 to 1000 with the difference of 50. It will be taking like that, and then the maximum depth of each decision tree, and then the minimum sample split. The samples will be splitted from 15 to 500 with a difference of 15. And then the minimum sample leaf node at the end, the leaf nodes from 5 to 50 with a difference of 5. Like this, this is a hyperparameter tuning type. So this will be applied again to our first will be applied to the randomized search CV. Why not for the grid search is because the grid search will take a lot of time. For there's many combinations here to see. So the better of is a random forest is randomized search CV. It will give us the best parameters so that we can search and apply it on the grid search CV. With the random search CV, we have gotten like this. So this particular, the random search CV, these are the values, but we will apply it to the grid search CV. This particular RF grid parameters were applied here. So that particular values are like this. So the base module is only doing better than the tune module in comparison to the F1 score and the accuracy, which are like better prediction for the how our model is doing, right? So yes, next is XGBoost classifier. So for this one, first thing is to for the base model, training the model and getting the evaluation score for the test. So this is how it is. F1 score is 0.94. For the hyperparameter tuning, there are two parameters: learning rate and maximum depth. This is one more parameter to consider for the XGBoost. So after performing the hyperparameter search on the random forest classifier, we got the best parameters as like this. So this will be applied with the grid search CV. So with that, we will get the parameters with the F1 score of 94. So both the base model and the tuned model have the same F1 score, but accuracy is better for the tuned model. So yes, I forgot to mention the accuracy is like to know like what is the model is predicting and how much of it is correct. And the sensitivity is what is the it's like division of what's the model is predicted and what's the actual result. It gets that percentage, and the specificity is for what's the negative that is the predicted, what's the actual negative, and then the predicted negative. So this also actual positive and the predicted positive. And then one second. Precision is it's like true positive by false positive plus false negative, like how much of the positivity has been predicted of all the true positive and true negative values. And F1 score is the mean of recall and precision. So it actually shows the better performance of the model. So for the model evaluation, if we see, so these are the F1 scores of all the modules that we have seen. So basically RF base model and SVC as like a better same F1 score. So comparatively, if we go for then accuracy, then SVC is better, but totally in the sense these two are performing in a same way. So if we further tune the model with the various attributes, there will be more parameters to consider. So if we go for that, then I think these two are in the find phase, RF and SV based model to predict the user sentiment. So that's what I am concluding it with. Yes. Yes, thank you, everybody. Hello?